Alright, this is the first video for this calculus portion of our class, and we are going to solve limits graphically and numerically, and we're going to start out with numerically with this equation right here. And so I'm going to make a nice little table here, and the x I'm going to plug in, and then we're going to find out what f of x is by plugging it in. And in the middle here, I'm going to have 2. So I'm going to start out with 1.9, get closer to 1.99, and then even closer with 1.999. Then I'm going to plug in 2.00. This should be 2.1, 2.01, and 2.001. So in the middle, we are getting closer to the number 2. Now, of course, if I plug 2 in here, we'd wind up with 0 over 0, and that's no good. But even so, we're not looking for what happens when we plug in 2. We're looking for what happens when x approaches 2. So I am just going to put these numbers into my calculator and see what comes out. Now, of course, I'm going to remind you, make sure you put parentheses whenever you plug these in around the numerator and denominator. And so I'm going to start this off with 11.41, 11.94, 11.994, 12.006, 12.06, and 12.61, which means that as we get closer to the middle, the x values got closer and closer to 12. And that's how we numerically do this. All you have to do is make sure you plug in the things properly. Alright, here we're going to do one that looks graphically, and we'll do several on this graph because this has different things going on. So the limit is x approaches negative 2. Now if you notice, as I come in from the left and as I come in from the right, the y value that we get closer to in both directions is the answer of 2. Now when we approach this same problem, except we're going as x goes to negative 1, as I come in from the left, I hit negative 2, and when I come in from the right, I hit positive 2, and since those numbers are not the same, and we have a jump in the graph, the answer is that this limit does not exist. Let us do the limit as x approaches 0. Now, as x approaches 0, it doesn't have a little dot or a little hole, it just is a regular old graph. And the y value when x goes to 0 is at 1. For the limit as x approaches 1, you'll notice I'm going to get the green in here. So the green goes to that one and goes to that one, and the limit as x approaches 0, 1 is 0. And this point up here, when we are doing this, doesn't matter. However, if I would have said what is f of 1, then you would have told me that the answer is 2, which means that the limit and the point may be in two different places. And then finally, if I want to do the limit as x approaches 2 at the end, that's just a regular old point there at negative 2, and all of these should have little f of x's in them, because we're talking about the same graph. And that is how you can look at a graph and see whether it doesn't exist or what number it approaches. Alright, so there were 3 different ways in class that we found out that limits don't exist. If there's a jump in the graph, if there's an asymptote, or if it oscillates too fast. And basically when we do this, when we're looking at a table, let's do the limit as x approaches 1 of 1 over x minus 1. We'll take a look at this in the table. And as long as you can tell what's going on, you should be okay. So we're going to start at 0.9, 0.99, 0.999, because we want 1 in the middle, 0.1001, 1.01, and I would put 1.1 in here, but I ran out of space. Once again, make sure we put this in parentheses. Alright, so when I plugged this in, that was negative 10, negative 100, negative 1,000, and positive 1,000, positive 100, and then if I would have had the opportunity to plug in the next one, it would have been positive 10. So that, go to 1 is positive 10. And as you notice, as we go to the middle, negative 1,000 and positive 1,000 are not close. Also, if you notice, these numbers are getting bigger and negatively bigger, or very, very negative, which means that these are heading towards an asymptote. Now, the important part of this, and the fact that we found out this is to be an asymptote because the numbers are changing so rapidly, is that the limit does not exist. Alright, finally, example 5 from the class was a piecewise function, so we are going to do the limit as x approaches 0 and x approaches 2, and we're also going to graph this. So, the way that I would graph this is, first of all, I would graph, and I'm going to do this one in blue, is I would graph x equals 2, y equals x plus 2, which we all should know is you start at 0, 2, up 1 over 1, and the graph looks like this. Now, because it says x is less than 0, that means that I need everything that is less than 0, and that because it's not equal to, this endpoint should be an open circle. Now, in red, I'm going to do 3x plus 2, which means I'm going to start at 2, and hey, we're going to fill that dot back in with the red graph, and then I'm going to go up 3 over 1, and I'm going to do that from 0 until 2. So normally we would have this graph go on forever, but here's 2, and that's where the graph stops, so I'm going to erase this other part. And then I have negative x, which I will do in green, where we start at 0, and we go down 1 over 1. And that one starts at x equals 2, so I have to erase the stuff that is less than negative 2, and an open circle right there. And put this graph back in, because we don't want to erase the axes. And so, if you notice, and I'll go to my graph, when we do the limit of f of x as x approaches 0, in both directions, it headed to the same point of 2. And of course I wrote this wrong, so let me fix this real quick. But we still get the answer of 2. Now when we take a look at the answer of x equals 2, I come in from the left and I come in from the right, and we are at two different locations. So the limit as x approaches 2 of f of x does not exist because we clearly have a jump. And that is the first section of Chapter 1. Actually, it's the second section, but the first section we did.